So under motion under gravity, under that section, we learned projectile motion. Now, what is a projectile motion? In a common sense, if you analyze that motion, when you throw an object at an initial velocity of u at an angle of theta with the horizontal, the object will take a path like this and it will hit ground. Time of flight, we take it as, sorry, here 0, here we take it as t. All right, fine. Now we considered certain aspects here. We discussed about the range. All right, so today we are going to analyze a bit more about this range. All right, now for range we learned an equation. Can you remember that? So the equation for range is 2u squared sine theta cos theta divided by g. That is the common equation we derived. That's correct when this is u and this is theta. And also we derived an equation for capital H2. Can anyone remember the equation for capital H? Capital H was equal to what? U squared sine squared theta divided by 2g. This was the equation for capital H. Now we are going to analyze capital R. All right. So the first point is this: you can throw an object at an initial velocity at different angles, people. This angle now can be 10 degrees, 20 degrees, 30 degrees. It will go on like that. Okay. It will go on like that. And 45, 60, it will go on like that. But if you want to get the maximum range, then you will have to draw the object like this now. Range, what I'll say, horizontal range. Horizontal range R, horizontal range R will be maximum when theta equals 45 degrees. That is the maximum value. Please try to remember that. I can prove it mathematically, but the proof is not very necessary since we're doing physics. If you can remember this, it's more than enough. All right, fine. But if you really want me to prove it, then I will just quickly explain. So this will be more convenient for the students who do maths. Now R is equal to 2u squared sine theta cos theta divided by g. All right. So this can be written as u squared over g into sine 2 theta. What is this? Because 2 sine theta cos theta, that can be written as sine 2 theta. That is something we study in maths. Now, for example, I'll quickly explain it. When theta is equal to 30, all right, then what is sine 2 theta? Sine 2 theta will be sine inside 2 into 30. That is sine 60. That is root 3 divided by 2. Let's use the other side of the equation. 2 sine theta cos theta. That will be 2 sine 30 cos 30. All right. So 2 into sine 30 is half, into cos 30 is root 3 by 2. So what is the value? Half and 2 will get cancelled off, root 3 by 2. Okay. So from this, you should be able to understand that sine 2 theta is actually equal to 2 sine theta cos theta. Okay. So you can change that equation to this. Right. Now we want R to be maximum for a particular value of u. We want R to be maximum for a particular value of u. For that, R will be maximum equal when, okay, u square over g, that's a constant, into this thing is maximum, sine 2 theta maximum. I hope you guys understood this. If you want this value to be high or highest, you want this sine 2 theta to be highest, because we are talking about the angle. All right, fine. So sine 2 theta maximum, people, for any angle sine, the maximum value is 1. Remember that the maximum value will be 1 for sine of any, because sine theta is between for acute angles. For acute angles, remember, sine theta is always between 1 and 0. Therefore, for acute angles, maximum value of sine is 1. Okay, so sine 2 theta should be 1, and we all know sine 2 theta max, that is equal to sine 90. 1 means sine 90. So 2 theta maximum, that is equal to 90. So theta maximum, that is equal to 45 degrees. That means when this angle is 45, R will be maximum. The second point is this: for two different angles, for two different values of theta, let's write like that. For two different values of theta, range will be equal. Now, you might be under the impression that when you change theta, range will also change. Obviously, now we are not changing u, keeping u same. We are changing theta and analyzing what will happen to R. So theta can be changed from 0 to 90. So acute angles, 0, 10, 30, 45, 60, 85, like that. All right. But as theta increases, the value of R will not keep increasing. For two different values of theta, R can be equal. All right. So wait, this is also a fact. Please try to remember this. I'll prove it lightly. Right. If you can't, if the proof is a little too much for you, at least for the sake of physics questions, try to remember the point here. If range is equal, for theta 1 and theta 2. Let's say theta 1 and theta 2 are the two different angles. Then this is the thing you have to remember. Then theta 1 plus theta 2 will be equal to 90. That is the first point. So what I'm trying to say is this: if theta 1 is equal to 30, now example, for example, if theta 1 is equal to 30, what is theta 2, guys? What is theta 2 then? It is going to be 60. So what I'm trying to say is, if you throw an object at velocity u and at an angle of 30, if the range is r, if you throw the same object at same initial velocity u, but now at an initial velocity, at an angle with inclination 60, for that also range will be r. That's what I'm trying to say. Okay, this is the meaning. Okay, that is one example. Another example, let's consider another example. Okay, example 2, right? If theta 1 is, let's say, 35. Now tell me, what is theta 2? Theta 1 is 35. What should be theta 2? Theta 2 should be what? 55 degrees. 55 degrees. So what is the explanation here? If you are throwing the object at velocity u, and if the angle is 35, for that instance, let's say the range is r. And if you throw the same object at same initial velocity at 55 degrees with the horizontal, then range will be still the same. But the maximum height reached will not be same. You can see in the diagram. 30 means it will be a low trajectory, but if it's 60, it will be a high trajectory. All right. So if you want to hit a 6, the best angle is 45. Why is that? When you hit the ball at 45, then only you will get the maximum range. People who have played cricket, you might have come across this situation. If you hit the ball flat, there's a chance of ball not going to six. There'll be 1 or 2 bounces to boundary. And also, if you hit the ball too high, what will happen? Catch near the boundary. Okay, so you can't hit it too flat, you can't hit it too high. You have to hit it moderately. Okay, so if you have played cricket and if you have hit a 6, then you will know this. If you have not done that, then unfortunately, no. So, right, so I think this is clear. If you want a mathematical proof, I'll quickly explain it. Now, let's see, when theta is equal to 30, all right, let's find out r is equal to, okay, what is the equation? 2u squared over g sine 30, okay, cos 30. So what is that? 2u squared over g. What is sine 30? Half. What is cos 30? Root 3 by 2. So what is the final answer? Root 3 u squared divided by 2g. This is the value for r when the angle is 30. And when theta is 60, what is r? R will be equal to 2u squared over g sine 60 cos 60 equals 2u squared over g into root 3 by 2 into half. It will be the same value, right? Root 3 u squared over 2g. Okay, so this is a small mathematical proof. Even for other angles, it will be the same. But we don't know the value of cos 35, sine 35, cos 55, sine 55. So let's not go there. So what I'm trying to say here is, please try to remember these 2 points. The points I have highlighted, one in blue and one in green. These 2. So these are the facts. This is how you can change the range of the projectile path.